So yeah, that's actually true. I am known as the most obnoxious man in cloud, not because I'm particularly rude, although I am, but because I have a habit of disagreeing with everyone about everything. And that's sort of on purpose. I think it's because I prefer conversations to monologues. And if everyone agrees with everything, the conversation ends very quickly. And so by disagreeing, we have a more interesting conversation. So I'm going to disagree with basically every other speaker at Gluecon, for fun mostly. But I wanted to kick off with a quote. I always kick off with a quote. And I'm going to talk a little bit today about designing APIs, which of course everyone's... Oh, by the way, this talk has nothing to do with what's on the schedule. I looked at the abstract I wrote originally. I was like, that sounds so dull. I don't want to give that talk. So I didn't. I wrote something else. So if you were here because you thought I was going to talk about that, you can get up and leave. I spent a lot of last week talking to lawyers. So just for the sake of anyone in the room who is a lawyer, I have a very lengthy legal disclaimer. I am not representing the OpenStack Foundation. I am not acting in a capacity as the director of either the OpenStack Foundation or any of the advisory boards I'm on. These are my own personal views. And if any of you are journalists, please make sure you preface any quotes by me with that statement. All right. So this is some stuff I do, and usually I talk about OpenStack or Cloud Foundry or stuff we've done at Piston, maybe even a little bit of OpenContrail or OpenDaylight or SDN in general. I get the sense that everybody here knows what OpenStack is, so I'm not going to talk about that. And probably a lot of you have already heard me tell stories about how we created it and why, and so we'll skip that part too. And I have ADHD, so I get tired about talking about the same stuff anyway. Show of hands, how many of you have actually heard of OpenStack already? Okay, that's easier than this used to be. But I had a really hard time preparing this talk because yesterday I noticed that the room is almost evenly split between developers and system administrators, or folks who call themselves those two things. And usually I would give a talk for developers, but I would force them to listen to me talk about something they don't want to talk about, which is how to make IT operations not suck. So instead I decided to talk about how to make things invisible. And I want us to talk about this because I think we can learn how to do it if we put our attention on it. You know, there's this whole idea of spending 10,000 hours to be an expert at something. But it's not actually the 10,000 hours that matters, it's deliberate practice. And so if you're not trying to do better at something, you're not going to get better. And I know a lot of us are writing APIs. How many of you have written an API? Awesome. Perfect. I think I'm in the right place. But the really important part about deliberate practice is you can tell you're doing it because you're uncomfortable. And so John yesterday from RunScope was talking about SDKs and how much he hates writing SDKs, and he makes them hate APIs. I think that's a great argument for writing SDKs. Not because the SDK itself is a good thing, but because it forces you to think about your API as a consumer instead of as an author. So let's get into this. Has anyone heard of Bistromathics? Has anyone read The Hitchhiker's Guide to the Galaxy? Okay, you've heard of Bistromathics. Bistromathics is the fake math behind the somebody else's problem field, which is the only proven but entirely fictitious way to make things invisible. And it involves bills in restaurants. Last week, Troy Toman gave a great talk where he put a bunch of Star Wars references in, and so I had to take all the Star Wars references out of all of my talks, and so I'm sort of ad-libbing here. But the usefulness of this is a picture of a spaceship. It's the invisible thing in the cricket field there. The secret to making spaceships invisible is not anything to do with cricket fields. It's that ignoring things doesn't make them invisible. And wishing that they were invisible will also not make them invisible. And I feel like this is a lot of what we do with API design, or in fact the relationship between the software that we're writing and the people that use it, is we ignore the users. We pretend they're not there. And we did an egregiously bad job of this inside OpenStack. OpenStack is basically a giant collection of APIs, by the way. It was literally API first. But that wasn't enough. It didn't turn out well. We didn't end up with good APIs because we wrote the APIs first. We ended up with bad APIs because we wrote the APIs first. And you can tell they're bad because we use SDKs inside OpenStack to have different components of OpenStack talk to each other. So that should be a warning sign. It's like we have code smells from the old days of refactoring. Now we have API smells. If you're using SDKs internal to your API, that's not a good sign. I really like to take concepts from outside of programming and force programmers to think about them, not because they're useful, but because stretching your thinking is also useful. So if none of this makes any sense, that's totally fine. Just trying to understand it might be useful. I could be wrong. But also it gives me something to fill my 30 minutes with, and I am determined to fill 30 minutes. Kidding. Also, you guys are all asleep. You didn't get enough coffee this morning. Okay, so let's talk about affordances. Has anyone heard of an affordance? One person, two people? Oh, okay, a couple people. An affordance is a term used usually in the design of physical objects. And it essentially says the handle that sticks out of a door is the affordance that tells you whether to push or pull. Right? It is the thing that interacts with it's not the user interface. It's actually the message that the user interface gives to the user about how to use it. So I'm a big believer in the fact that if you are writing documentation, you have failed at designing your product. A great product doesn't need documentation. My now ex-stepfather, there's no good term for that, by the way, but my now ex-stepfather worked for Jobs in the early 80s, and he recounted a story about being at Apple headquarters, I think 1983, 84. Jobs had recalled the entire worldwide sales force and put them in a room, and they were talking about products, and this was, coming up to the Mac launch. It was before they all got on planes with early Mac demos and went to go sell them. And he had everybody in the room, and he wheeled up an arcade machine onto the stage, made everybody wait while they plugged it in, and he got out a quarter, and he went over to the arcade machine, and he said, the user experience is defined as the number of quarters it takes to figure out how to play the game. The Mac is going to be 1 quarter. He put the quarter down and he left. That was the end of the meeting. And so I feel like that's true of APIs as well. If I have to read your documentation to understand how to use the API, it's too many quarters. It's not fun. So everyone talks about this sort of if you have a hammer thing. The users are the nail. They are tired of being beaten upon. Right? So let's stop thinking about everything as if we have a hammer and start thinking about things as if we were the nail. What's that experience like? Your API is not a natural extension of your code. It is not a coding process. It is a product. You should think about it as product design first, which means thinking about the users that are going to consume it. And I'm going to drill into why I care on the cloud side of this in a minute. But first I want to talk about Jobs. Actually, I want to talk about Wozniak. I am not exactly an Apple fanboy, but I think it represents some moments in history that are illustrative. This was the first affordance of the PC era. And Wozniak has a famous quote where he basically said he owned a television and he owned a typewriter, and so he sort of imagined that a computer ought to feel like a typewriter in front of a television. And it seems like a trivial comment, except that every single one of you have a typewriter in front of a television in front of you. And it seems obvious after the fact. Simple is really, really, really hard to do, but really easy to look at afterwards and goes, well, that was obvious and simple, except nobody else had done it that way. So the important thing about this affordance is not that it's a typewriter in front of a television. The important thing is that you didn't have to be a hardware engineer to be a software engineer. This box created software engineering as an independent discipline. It was the first time, and this, by the way, not that particular box, but an Apple was the first computer I ever used. It was how I learned to program, and I have never been a hardware engineer. How many of you have ever built a flip-flop? Yeah, less than half, way less than half. That's because of this. Pre this, in order to be a programmer, you logically had to understand hardware engineering. Even if you weren't soldering circuits down, there was so much of hardware engineering exposed in how you were doing programming that you couldn't not understand what was going on under the hood. And we still have this problem today in how we're thinking about cloud. We're forcing application developers to know way too much about servers and networks. So, my name is Joshua McKenty, and I'm an addict. I'm addicted to details. And I think most of you are. I think we should have just a little Detail Addicts Anonymous meeting. I don't know, this is not even a thing, I just made it up. How many of you know more than one programming language? More than 2? More than 3? More than 4? Okay, yeah. We are addicted to details. That is our personality. It is our natural state. We know which languages require semicolons and which don't, which ones have syntactically significant white space, which ones require you to drop a duck on a keyboard in order to generate useful code. That would be Erlang. I figured this was a safe crowd to make fun of Erlang at, by the way. It's, so far that's working out. The reality is we're the kind of guys who find this joke extremely funny. Right? Being right actually doesn't matter. Having an API that faithfully represents what's happening under the hood is not a good affordance. That is too much transparency. It's not helpful. So let's use a specific example of this. Let's say you have an API that exposes a duck. Okay? And I wanted to use a different animal, but most of the other animals already have associations now. So, and I am making fun of Erlang. This is your view of the duck, right? It has skeletal systems and muscular systems and digestive systems and all sorts of parts, gizzards. If you ever write an API that exposes the gizzard, you are a cruel and unusual person. This is the right way to create the affordance. The mental model of your user should think that they're dealing with a duck, which means your mental model, when you're drafting that API, needs to be thinking about it as a duck and not say, oh, I'm on the team that's on the gizzard API. I'm on the team that's on the wing API. Because then what happens is your user has to reassemble the duck in their own brain. At which point, why the hell do you have an API? So I come back to Adam's statement earlier about saying, hey, IaaS is this obnoxious layer we should get rid of. And I agree, because we've built it wrong. We've exposed all of these internal body parts of the duck instead of saying, oh, here's a duck. There are responsibilities that the IaaS has that makes me think we can't get rid of it, mostly about multi-tenancy and sharing resources. Assembly lines were built to build one kind of car. So when you're using an assembly line analogy, yeah, obviously IaaS is in the way. But when you start thinking about a shared resource pool, you need something that's in charge of making sure the sharing is fair. The other way to think about this is that, how many of you have done object-oriented programming? Okay, or still do? Right. So a REST API is not for exposing objects. It's for exposing resources. An object is your problem. A resource is the user's problem. So an affordance is the way of translating objects into resources. And by the way, it's not one-to-one. A resource probably composes a whole bunch of different objects together, just like a duck is composed of a whole bunch of different systems. Now, if you need APIs internally that are the Gizzard API and the Wing API and the Blood Flow API, and you want to compose those into a higher order API and then give that to your users, fine. But just know that that's what you're doing, and probably write the duck first. All right. There is no way to put a duck API on top of a water buffalo. If it's not a duck underneath, you can't really make it look like a duck. It's not going to map out properly. Which means in order to have a great API, you need to fearlessly change the product underneath. So one of the things that Wozniak did a great job of with the Apple II, well, the Apple I, and certainly the Mac, is they just totally changed what it meant to be a computer. And I was looking at that wooden case, and I hadn't thought of this before, but the striking thing is it has no lights. And most computers in those days were mostly blinking lights. You had to know what each of the lights meant. It's one of the annoying things about lights as a feedback mechanism, is that you have to know if it's on or off, what does that mean? If it's a different color, what does that mean? Right? Whereas the idea of just using a screen was a really powerful concept. So throwing stuff away in the affordance is something Apple has done incredibly well for a long time. I hate keynotes that sound like a product pitch, so I sort of promised myself I wouldn't talk about Piston or what we're doing, but I will hint at, we've been throwing a whole bunch of stuff away. We threw out the OS. People keep saying, well, does the OS matter? No, it doesn't. We don't ever install an OS on any server as part of our OpenStack deployments. We've thrown out the idea that you even know which server in your cluster is running any particular service. Just trust that it's running, and it's always running, and you can go and pull power plugs out of servers over and over and over again. The service will keep running. It's going to get master elected somewhere else. That freaks sysadministrators out. It's actually made it harder to sell the product because they're like, no, I need to see the Puppet recipes. Tell me how this is working under the hood. They're addicted to details. And if they don't get to install the OS themselves, it makes them panic. But you're never going to get to dealing with just ducks if you're addicted to these details of, what flavor is the OS and where is it installed and how are the partitions mapped. I've been told that, that's way too simple a concept to scale, that you could never build a large cloud out of that approach. And actually, simple is the only thing that does scale. What's odd about this Cloud Foundry, how many of you know what Cloud Foundry is? Okay, so OpenStack has a ridiculous number of APIs. It's got 80 projects, and every project has, way too many APIs. But Cloud Foundry only uses about a dozen of them. Turns out most of those abstractions are not really what the applications need, at least not yet. Partly, I think that's because we built things that are like not even gizzards. They're parts of other animals that are not even part of a duck. And so there's really no way to expose them as part of a duck. All right, I'm going to move on a little bit. This is all credit to Donnie Burkholt. We were talking about this earlier this week. This is the accordion metaphor. So I'm going to give credit to Donnie and Redmark, and then I'm going to tear it apart. The idea is that there's a natural tension in IT between convergence, which is lots of things getting folded down into one thing. Hardware convergence is a great example. Your phone is perfect device convergence, right? Used to be a PDA and a GPS and a phone and a pager and a calendar and I don't know whatever else. Now it's a camera, right? Cameras. I remember when I had a camera. Now it's just one thing. But the reverse is composability. This was what Donnie was blogging about earlier this week, and that Unix and the entire Unix system philosophy was small things loosely coupled, and where you can deal with each small thing if you want to. Right. And so there's this natural tension between convergence and building monolithic things and having a whole bunch of small composable things. Donnie's thesis, which I think is legitimate, is that during innovation, you need composability so that you can keep mixing and matching and you can play around with how things are integrated. But as ecosystems mature, there's a natural convergence of functions so that they're easier to consume and so that a wider audience of folks can be involved in using them. I think this is true in the past, but there's a huge problem with doing this today. And the problem is called the mobility gap. How many of you have heard of this? Awesome, you're going to learn something. Okay, I have a totally different way of explaining this that's Moore's law, Nielsen's law, Kreider's law, and I'm really bored of that. So as I mentioned, I have ADD. So I'm going to explain this instead in terms of making pizza in the 1500s. And let's say you're at your kitchen counter and you've got some flour on the counter. So you start with the flour, and that's 1 second to get the flour. It's right there. The cheese is in the cheese shop down the street. I don't know how many of you have been to Italy, but there are shops just dedicated to cheese, which is amazing. So you go down the street and you get some cheese, and that takes you 5 minutes. The tomatoes are in the New World. So that's a 12-month round trip. So your pizza can't be delivered as a service. You can't make Domino's in the 1400s. Right? This is comparable to this chart on the other side. If a CPU cycle was 1 second, which it's not. It's much less than that. But let's say it was 1 second. If a CPU cycle was 1 second, reading from disk, from rotational media, will take you about 12 months. And people have a hard time getting their head around that. That's such an order of magnitude, several orders of magnitude larger. And then, you know, an internet connection from San Francisco to New York will take 4 years. When you're thinking about distributed systems, and a number of folks have pointed out quite rightly that we don't build applications that can run on a single server anymore. Ever. Doesn't happen. Everything we build is going to run on multiple servers. You can't ignore the network. So I'll go back to the formal definition. Moore's law, computing is getting faster. Kreider's law, storage is getting more dense. Nielsen's law, networks are getting faster. But Nielsen's law can't keep up. It never has, it probably never will. There's some evil material science problem or the speed of light or something. Distance cannot be eliminated. And so the cost of moving data is our #1 bottleneck, and it's getting worse every day. It will be dramatically worse next year, and it'll be even worse after that. So when I hear people say, oh, fog computing, we're going to do cloud computing on the edge, what a dumb idea. This is where you realize I am the most obnoxious man in cloud, right? What a dumb idea, because if you stick your data on the edge, and your edges are by nature as far away from each other as possible, it is the Internet of Things, your mobility gap is huge. It is front and center. It's all you're dealing with now. So you can't build a duck with an infinitely large wormhole in the center of the duck. I'm tearing this metaphor apart, but... Okay, so what do? We want to hide things, but there's this giant elephant in the center of everything we're trying to hide, and we want to throw things out and change the definition of our product, except we really can't because we need people to be able to understand what it does. I'm going to leave you with a thought, which is I'm totally not going to resolve this problem for you. Just so you know, this is why I'm provoking a conversation. We have to do everything. So this is one of my favorite comedians, and he gave a commencement speech at a university, which I thought was brilliant. And it also is the only quote I could find on the internet that's about this term called yes and. Have any of you ever done improv? Stand up? No? A couple of you. Okay, so the thing with improv is when somebody suggests an idea, you have to go along with it. It's called yes and. You never say no. Because if you say no, the joke ends. Then you have to start something entirely new, which is probably not as funny. So if you start out and say, Dr. Schmidt, why are we in this ice cage? I've totally messed that up. Ice cave. Can't say that word. The other guy's got to go, I don't know, but the polar bear is coming. He can't say I'm not a doctor. He can't say I'm not in a cave. He's got to add something else. And this is true in IT, right? Mainframes have never gone away. There's some rough estimate, there's about 30,000 mainframes still in production. They're never going to go away, right? So you've got legacy and modern. You've got PaaS and IaaS. You have fast things and slow things. You have automation and humans. If you're familiar with Agile and Lean and all that stuff, it all comes from early 1900s in Toyota, which the idea behind it was automation with a human touch. The goal was never 100% automation. That doesn't work. The goal is just to keep people doing the part that they can do really, really well. High value, high intelligence. And the last piece is you're going to have open and closed systems. And I know I'm the heretic to say it's not all going to be open source forever, but it's not all going to be open source forever. Right? OpenStack was deliberately started with an Apache 2 license so that we could have an ecosystem of folks that were contributing to open source and folks that were building weird differentiated commercial things. I think almost every company I deal with on a daily basis that does open source also does commercial things. And I think that's really healthy. I think when you're deciding what your stack is going to look like, how are you going to build your API, how are you going to deliver it, what kind of infrastructure you're going to use, you're making choices about open and closed at every part of the stack. You don't have an open specification for power. You only accept 110 at 60 hertz or 220 at whatever. You have a single power spec that you use. It's not an open model, and it doesn't really have to be. You can buy from multiple vendors behind that standard. but you frankly don't plan on swapping out your power supply, right? You may or may not be using an open BIOS. Doesn't really matter to you. You may or may not be using open firmware on any one of your devices. May or may not matter. Some of those things are open standards, some of them aren't. What you care about is the abstraction where you're getting work done, the edge of innovation. You need that to be open. Right? And this is back to that accordion. There are parts of the accordion that are collapsing and parts that are expanding. Where the accordion is making noise, pay attention. The rest of the accordion, who cares, is flopping around. Okay, so now I've got accordions and ducks. My number of metaphors in this talk has gotten egregious. Cloud Foundry, same idea. Same license, same ecosystem, lots of commercial support, lots of open source, works on all of the different clouds, public clouds and private clouds and whatever else. How many of you are flamenco dancers? Hey, awesome, we got one in the back. You could be. You all are reasonably tall. I've noticed at this conference there are more tall people than most tech conferences. I don't know if Eric sort of selects for that, but I have noticed it. The point is, we're all above average. We're all smart and good looking. We are good at many, many things. We are not good at all things. And that part of that addiction to details is that we have this feeling that everything would be better if we did it ourselves. Right? This is called not invented here syndrome, but I see it all the time in cloud. It's like our language is better than that language. Our library is better than that other library. We're going to write another version of X because we didn't write the other version of X. Jeff Lindsay and I were lamenting this yesterday, the number of Raft implementations right now. I think Raft is a great idea. Something better than Paxos. Oh my God, thank you. But there are how many new, different, competing implementations of Raft now? So the point is we're not good at all things. We're only good at some things. And that's kind of where vendors are handy. Vendors can be good at things that we don't care about, or they can be good at things that we don't have time to be the best at. All right, a little bit of wrap up. Think about building a somebody else's problem field. Think about deliberately trying to make a vast portion of your application totally invisible, not by actually making it invisible, but by making it something that people don't have to care about. Give them an abstraction that solves their problem instead of exposes your problems. Break your addiction to details. Try, I don't know, not checking email. Something. Not installing OSs. Think about affordances. Think about the interfaces, not just that people use, but the way that you hint to them that they could use it. Right? And it's not documentation. Mind the mobility gap in all of these other problems. And finally, it's a yes and solution. This is not a there is a right way to do it. There is many right ways to do it. Adding APIs to legacy code, gonna have to do it. Yeah, it's not pretty, it's not fun, it's not sexy, it doesn't look good on your resume. You need to do it anyway. All right, I have 1 minute and 30 seconds left for questions.
Do we have a 1 minute and 30 second length question? They're all longer than 1 minute and 30 seconds.
If you want me to go back over the duck meets accordion part.
I was just going to say, I think I heard you volunteer to be giving flamenco lessons at next year's Gluecon.
That could actually, yeah, probably.
We've got a pavilion outside. We can utilize that.
Nice. So. Thank you. I'm going to need a lot of alcohol.
Joshua, thank you very much.
Sure. Thank you.